All right, so before we start this on cross products, I'd like you to take a second and read pages 790 to 791, just so you can get an idea of what I'm about to talk about. So if you haven't done that yet, pause this video, read page 790 to 791 in your text, and then come back, all right? So assuming you've already read these pages, what they talk about is the cross product. Now, we just finished talking about the dot product, and one of the things I said is the dot product isn't really like an object. It's really a number that's used in a lot of different cases. The cross product, however, is an object, and the cross product of two vectors is a way of creating a new vector that is perpendicular to two given non-parallel vectors in space. So if you have two vectors that are non-parallel, you can take their cross product, and you will get another vector. That vector is going to be perpendicular to your original two. Now, technically, you can cross parallel vectors, but when you do that, something different happens. I'm not going to give it away now, but something different happens. So let's say I have these two vectors in space. The next vector, when you do the cross product, is going to be this thing, and it's perpendicular to the plane defined by these two vectors. So imagine that these two vectors are on a piece of paper. This is a pen sticking straight up. Okay, so that's one visual way of looking at the cross product. I apologize. I am a terrible, terrible artist. Without the smartboard, I probably couldn't draw a circle. All right, how do you get a cross product? Well, let U equal U1, U2, U3, and V equal V1, V2, V3. Then the cross product is U2, V3 minus U3, V2I. Okay, I don't even want to keep reading this. You know why? Because it's obnoxious. You don't need to memorize this formula. What you do need to memorize is that the cross product is really the determinant of a matrix. So when you find a cross product, you make a 3 by 3 matrix. That's this box right here. The first row is IJK. The next row is U1, U2, U3, the three components of U. Next are the three components of V. To get a cross product, what you do with these is you take I and imagine that you cross everything off in its row and column. Then you multiply U2 and V3, and you multiply U3 and V2 and take their difference. So it's I times this cross product right here. Then you subtract, this is key, the next term, J. Imagine J's whole row and column are eliminated. U1 V3 minus U3 V1. And then last but not least, K, eliminate its row and column, U1 V2 minus U2 V1. So to make a cross product, what you're really doing is you're finding the determinant of a 3 by 3 matrix. If you don't know anything about matrix multiplication or matrices in general, don't worry about it. Just remember this is a visual representation of how to get a cross product without having to memorize the products and the differences that you need, okay? So first, we'll just do determinants really quick. A determinant of a 2 by 2 matrix is when you have 4 numbers and they're in a box, and the determinant is top left times bottom right minus top right times bottom left. So 8 minus 28 is negative 20. Every single time, if you want a determinant of a 2 by 2, you just take the cross multiplication and then subtract. So 3 times 7 minus negative 2 times negative 5. That's going to be 11. And then negative 3 times 4. 8 times negative 9 is negative 72, so I'm making that a plus. And I'll get 60. There's determinants of 2 by 2s. Now, we're going to find the determinant of a 3 by 3, and then we'll apply it to the cross product. So when you find the determinant of a 3 by 3, in ours we're going to have I, J, and K up here. For now, I'm just going to show it to you with numbers, and then we'll put back the I, J, K. So if you want the determinant of a 3 by 3 matrix, you take, don't write this on your paper, just watch me. You take the 3, and you pretend to eliminate the row and column that the 3 is in. So I have 3. And then you multiply 3 by the determinant of what's left over. So this 2 by 2 matrix that's left over has a determinant of 60 minus 7. Then I erase that, and now I take 8, eliminate its row and column, minus 8. You negate the second term. And then 8 gets multiplied by the determinant of what's left over. 9 times 6 is 54, minus 1 times 5, which is 5. And then last but not least, you go to the 2, and I circle it, eliminate its row and column, plus 2 times 9 times 7 is 63, minus 10 times 5, which is 50. And that is going to get your determinant. So I have 3 times 53 minus 8 times 49 plus 2 times 13, which is going to be what? 159 minus 8 times 49 is 392. So then what you should get with that one is you should get negative 207 for the determinant. And that's just a single number. All right, so why don't you try and do this next determinant on your own, and then I'll go through it rather quickly. Hit pause, try to do it on your own, and then come back and we'll go through it together. All right, and hopefully you did that determinant. It looks a lot like this, and you got negative 14. I'm not really going to spend a lot of time going over it. Just make sure the second term gets negated. Mine says plus, but it's because it was a negative 2. All right, now, for what we really need to do, calculate the cross product for each of the following. All right, so U cross V. So again, what is a cross product in terms of vectors? It is a new vector that is perpendicular to both U and V. And if you were in my class right now, I'd be holding 2 yardsticks out in front of me and then poking a pencil at their intersection to make a right angle. It's kind of like the corner of an open top box is one way to think about it. So anyways, if I want to calculate the cross product, here is how that works. So U cross V is the cross product created by the determinant I, J, K, 2, negative 4, 5, 2, negative 5, negative 3. So I times this leftover piece here. So I cross off the row in the column, now multiply by the determinant of down here. So I have negative 4 times negative 8 is positive 32, minus negative 25, which is going to be plus 25, minus J times, J's row and column are eliminated. 2 times negative 8 is negative 16, 5 times 2 is 10, plus K. K's row and column are eliminated. Determinant of this, negative 10, minus negative, so plus 8. And I end up with I times 57 minus J times negative 26 plus K times negative 2, which is really the vector 57, 26, negative 2. That thing right there is perpendicular to both U and V. Okay? So let's see, I'll do C with you, and then I'll pause it, and you can do B and D on your own. So if I were to do C with you, U cross V cross W. So now I'm going to take I, J, K, parenthesize, fake parenthesize these two, and say U cross V, I've already done, it's right here, is 57, 26, negative 2. I don't know why these little dot boxes are showing up, sorry, it's something with the driver. Anyway, so I have that, and then I'm supposed to cross that with W, and W is 109, 109. All right, so I have I times 26 times 9, which is what, 260, take away 26 is 234, 4, 5, yeah, I think that's right. 234 minus 0, so that's nothing. I minus J. J is 57 times 9, which is 570 minus 57 is 513, minus negative 2, which is going to be plus 2, then plus K. 57 times 0 is 0, minus 26 times 1, which is 26. So I have 234, negative 515, and negative 26 if my arithmetic is all correct. By the way, if you ever see me do something and my arithmetic is not correct, please shoot me an email. I'm trying to take care of technology and writing and teaching Calc 3 and doing math in my head all at the same time. I'm bound to make a mistake. I promise I can math, but sometimes just not while doing other things. So there's your cross product. I want you to take half a second, pause it, do B and D, and then come right back. So barring any arithmetic mistakes here, you should end up with a cross product of negative 45, negative 21, and 7. And then this was a dot with a cross product, and that ends up giving you a scalar of 39. All right. Funny little meme down here. I don't always make a sign error when evaluating the cross product, but when I do, it's on the middle term. Make sure you remember that you are subtracting the cross product when doing J. All right. Doesn't mean you're negating J. It means you're negating the value of that leftover determinant. So it doesn't always have to be a negative value, but it has to be a negated value from what you would originally get. All right, and last but not least on this last page, geometric properties of the cross product. If u and v are non-zero vectors in space and theta is the angle between them, u cross v is orthogonal, also known as perpendicular, to both u and v. The magnitude of the cross product is actually the magnitude of u times the magnitude of v times the sine of the angle between them, which goes right with 4, where if the magnitude of u cross v is uv sine theta, let's say I have u right here and I have v right here, okay, and I were to do something like that, I'd have a triangle, right? Isn't this kind of like AB sine C? Do you remember the formula 1/2 AB sine C? 1/2 AB sine C is the area of a triangle. So if the magnitude of the cross product is just regular AB sine C, what that actually means is the magnitude of the cross product is the area of the parallelogram with u and v having adjacent sides, which means you could actually put another one in here and say 1/2 the magnitude of the cross product. So 1/2 the magnitude of this cross product is going to be the area of the triangle created by u and v. All right, so the uv sine theta is the magnitude of the cross product, also known as the area of the parallelogram, and half the magnitude of the cross product would be the area of a triangle. And then last but not least, u cross v is the zero vector. Notice how that's a bold 0. U cross v is the zero vector if and only if u and v are scalar multiples of each other. In other words, u and v are parallel. Okay. All right, so let's say I want to show that u cross w is orthogonal to u and w. Well, orthogonal means perpendicular, and things that are perpendicular have dot products that equal 0. So I want to show that u cross w dotted with u and u cross w dotted with w both equal 0. So first I need to find u cross w. So I, j, k, 2, negative 4, 5, 1, 0, 9. And if I want to find the cross product here, I'm going to have I times negative 36 minus 0 minus j times 18 minus 5 plus k times 0 minus negative 4, which is going to give me negative 36, negative 13, and 4. So if I take that cross product and dot it with u, 2, negative 4, 5, I'm going to get negative 72, positive 42, positive 52, and positive 20. That equals 0. So therefore, the cross product is orthogonal with u. Now let's take the cross product and dot it with w. And negative 36 plus 0 plus 36 equals 0 again. Therefore, U cross W is perpendicular to both U and W. All right, now, last but not least, one thing you need to know is the cross product is not commutative. U cross W does not equal W cross U. U cross W is the negation of W cross U. So we have something to go with the cross product called the right hand rule. With your right hand, you point your index finger along A and your middle finger along B, and then when you do A cross B in that order, the cross product goes in the direction of your thumb. Now, I used this because I could use this nice picture that I found, and it was kind of funny. I actually do the whole right hand rule instead of the right finger rule, and I don't just point my entire index finger, I point my entire palm along vector A, and a way in which I can curve my palm toward vector V. Now, unfortunately, I can't show you this right now. Maybe I'll videotape myself later and put it in for you to watch, but I don't have a video of myself doing this, so maybe we can do that later. But anyways, if you want to know what direction your cross product goes in, you can do this. The only other thing I wanted to talk about in this video is the fact that when you want a cross product, or when you're doing a cross product, I should say, what you end up getting is a perpendicular vector. Now, that's not the only perpendicular vector. It's a perpendicular vector to the other two. Every other perpendicular vector like that one is going to be a scalar multiple of it, because there's really only one direction perpendicular to two other intersecting vectors that are non-parallel. All right? So your cross product gets you one magnitude of a vector that's perpendicular to your original two vectors. All right? That is that. All right, so we got to end with a joke. Let's see. The joke we'll end with today is, why did Noah go to State Farm? Because Noah wanted flood insurance. I know, that one's not that good, but it's Monday when I'm recording this, so on a Monday morning, that's what you get. Have a wonderful evening, morning, whatever, and we'll do more math later.